Hi, I'm an old guy and I do maths. Now, this is a kind of interesting problem because we're not going to solve it in the normal way. Um, the problem is a vehicle travels 45 kilometers in 30 minutes. And the question is, how do we calculate its speed from a graph? Now, those of you who do physics or a modicum of general science will know that there's a relationship between distance, time, and speed or velocity, and that we can formulate an equation to solve this. But I thought what I'd do is show you how that would be illustrated on a graph, and at the same time um, deal with a couple of features of that graph, such as what's called a rate of change, because here we are going to have a rate of change. It's going to be a constant rate of change as far as we're concerned because we have no other information. Now, how do we graph this? Well, time usually runs across the bottom as an x-axis, and distance we will have up the side here. So what we're going to do is we're going to do time in units of 10 minutes. So 30 minutes is our limit out here. This thing only runs for 30 minutes. And in terms of distance, we'll break this up into three parts as well. We'll go 15, 30, and 45. So we're going to assume two things. One is that we have a constant speed because we have no other information. The other thing is that we're going to assume that the car or the vehicle starts here at 0 and runs for 30 minutes and travels 45 kilometers. Now, if it does that, it creates a coordinate on the graph that is 30 minutes, that's the x value, and 45 kilometers, which is the y value. And that's our point here, 30, 45. And if it started down here, the coordinate here is 0, 0. And I'll just sketch in a line. This is meant to be a straight line. Now, what this straight line tells us, because again we have no other information, is that the speed, which is distance over time, was constant between 0 and 30 minutes. We have no other information, so we just assume that. Now, what was that speed? Well, that speed, and apologies to the physicists who like to say velocity, that speed is equal to the gradient of this straight line. How do we find the gradient? Well, it's y2 minus y1, get it round the right way, over x2 minus x1. So, y2, x2, x1, y1. Okay, so let's go to work. This will be relatively simple. Y2 is 45 minus 0, which of course is 45. X2 is 30, which of course is then has 0 subtracted from it. So the gradient is equal to 45 over 30, which we can greatly simplify. Now, we've done this in minutes, and so what we're going to get from this is we're going to get a speed or a velocity in minutes. So that's going to be slightly different from what we expect. What I'm going to do in a moment is I'm going to redraw this graph and recalibrate it so that we have units down here that are in hours. Okay, so what do we get here? Well, what we get is how many 9s in 45? Well, sorry, how many 5s in 45? There are 9. How many 5s in 30? There are 6. And so that is 3, and that is 2. And that is 1.5 kilometers per minute, because we calibrated this in minutes. Now, let's recalibrate, and we'll do this in hours. So we've still got the 15, the 30, and the 45 kilometers here. 30 minutes is 0.5 of an hour. We don't need to bother about the other measurements, because we've really only got data for 0.5 of an hour. So our point up here is now 0.545, and our line remains the same. And this is time in minutes, this is time in hours. And if we just do this quickly, given that these are 0, you can see the equation here. We're just going to change these numbers. It's going to be 45 minus 0 over 0.5 minus 0. That equals 45 over 0.5. 45 divided by 0.5 is equal to 90. The speed is 90 kilometers per hour. And we get that from that graph. It's kind of arcane, I suppose, but you ought to be able to read and understand one of these graphs and see what it tells you. Anyway, that's the answer in minutes, in kilometers per minute, and in kilometers per hour. I hope you found this useful. If you did, please like and subscribe, and I'll see you next time. Bye.